Hi, friends, and everybody else. As Drew mentioned, my name is Andy Andrea, based in Durham, North Carolina. I've been working with Rails professionally for a little over a decade at this point. And in that time, I've used the Rails validation library quite often, sometimes too often, sometimes not quite often enough. And a couple years ago, I started working on an application that has a pretty customized in-house data access layer. It's an event-sourced application where we have tons of events moving through the system as hashes, as value objects, no active record, no real model layer in the traditional Rails sense. And about a year ago, I was tasked with coming up with a way to validate that our events make sense, they're not corrupted, they have all the data, all the shape that they need in order for the system to function. And I was told that that validation library should be a single class. We didn't want to have to make new classes for every type of event and then register the validations on all of those classes. And so I thought, well, that isn't very Railsy, but it would be great if I could figure out a way to use the built-in Rails validators, because then we don't have to worry about maintaining them, we don't have to worry about documenting them, we don't have to worry about reinventing the wheel, and just to get a fraction of the power that we can get from Rails. And so I decided to give it a shot, and it's actually been in production for a little over a year now. So it worked, kind of to my surprise. And today I will not be showing you that code, but I will in fact be showing you something that I think is much better. So for anyone that might have snuck in from my work, please don't fire me for that. I am going to assume that everyone has some experience with Rails validators in this talk, but I'm going to take a little bit to just establish some shared language. In case anyone is wondering why my slide theme changed from slide to slide, it is because I procrastinated and did not know that there was an official slide theme, so we're stuck with the first one from Google Slides. Similarly, I'm kind of living life on the edge because I did not change the batteries in my remote since Atlanta, which for those of you who don't know, was 2 years ago, so we will see how this goes. But so, back to topic. With our Rails validators, we kind of have two sides to the same coin, classes and instances. And at the class level, we have methods that I'm going to say are used for registering validations. These are things like validates, validate, validates with, validates presence of. There are quite a good number of these if we look at our Rails models in Rails 8. And on the flip side, the instance level, we have still a good number of methods, 27, but only 4 are really relevant to what I think the instance methods often typically do, which is running validations that have already been registered at the class level. And those methods are valid, invalid, validate, and validate bang. So again, class level, registering your validations, instance level, running the validations. And as far as we're concerned, we're just going to be talking about ActiveModel today. We do have some validation logic that comes from Active Record. It's typically the stuff dealing with the database, uniqueness, associations, and the like. But in ActiveModel, we've got the validations directory, the validations.rb file, the validator.rb. Great thing about being a speaker is sometimes you just pronounce words like validator for no apparent reason. The validator is basically where the base classes live. Validations directory is where a lot of the validators, like the presence validator, the numericality validator, and the like live. Validations.rb is kind of a lot of the helper files, bringing it all together. And so I mentioned before that I really like, and in some cases have probably overused, Rails validators. There have been a couple of situations, though, where I've wished that they work a little bit differently. And that makes sense. It's a convention over configuration framework. So those things are, I've sometimes wished that I could use them with non-model classes. I've had a hash, like in the example I gave earlier, where I wanted to validate the key value pairs rather than the columns and the row values associated with a particular model. And I've also wanted, in certain cases where I've had very complex validation logic with tons of conditionals that says this validation should run or this validation shouldn't run, I would have liked the ability to compose my validations on the fly rather than having them all registered at some global class level in my application. Additionally, I've run into some situations where I've maybe had a param that comes in a controller that should affect whether or not some validations run or don't run. And since validations are all at the model level, that means you have to get that data into the model. That might mean making a new ActiveModel model. That might mean adding some kind of a new attribute or adder accessor to your existing model and putting that in where it's sometimes used, but oftentimes not that relevant. And really, there are ways to get around most of these. Most of them involve just making a new class. But sometimes it would have been nice if we didn't necessarily have to go that approach. Sometimes that might feel a little bit heavy-handed to us. And so the question is, do these things matter? I would say no, not really. But since that's really bad marketing for this talk, I'll say please don't leave just because I said that. And so in this talk, we are going to assume that these things are at least worth considering and worth investigating. And so our goal by the end of this talk is to have a validator class that can run Rails validators against any kind of input, whether it's a hash, whether it's a model. We're going to do this without any monkey patching, without any kind of typecasting or coercion. We're also going to have it have its own independent state at the instance level, so nothing global, nothing dependent upon any other validations that might have been registered in your system. And we're also not going to care about the shape or the structure of that data. If you have hashes in an array, it's going to work. If you have hashes that are deeply nested, it's going to work. If you've got a mixture of hashes and models, it'll all work. So to get started on that, we're going to start off with a fairly simple proof of concept where we're just going to say we want to run the Rails presence validator against a hash. And so to get started, we can look at the source code for presence validator, and it's actually really simple. This isn't the whole thing, but it's most of the logic in there. There's some extra comments, a little helper method, but this is the entire validate each method, and this is really the only public method that we see on presence validator when we look at the source. And it's pretty simple. It takes in a record, which is typically going to be an active record model in our typical use cases, but now is going to be a hash. The adder name that would typically be a column on a table is now going to be a key in that hash, and the value is going to be the value associated with that key. And so it's very simple. We add an error if the value is blank. And so we're going to start off with something very, very naive. Create a simple validator class that takes in our object to validate, our hash in the constructor. We've defined a validates presence of method that takes in some keys. This would be like validates presence of first name, last name are the keys, and accept our normal options that we would normally pass into Rails. So we can just instantiate our presence validator. We do have to pass it those keys as the arguments to the constructor, iterate over the keys, grab the value, and then call that validate each method that we saw. And like I said, this is very, very naive. It's very, very simple. And because of that, you might be very pleasantly surprised to know that this doesn't actually work. If we call this little proof of concept where we want to say that we're validating the presence of presents, maybe it's a Christmas themed app or something, then it goes boom. But it doesn't really have too many issues. There are only 4 errors that we have to solve before this runs. Rather than going through them one by one, I'm just going to show them all off. So first off, we get undefined method errors. If we think back to that presence validator source code that was doing record.errors.add, our record is our hash. It doesn't have an errors method. This makes sense. That's something we'll have to fix. If we fix that up, we'll see that we've now left the presence validator behind, and when we're building up the errors themselves, we see no method for read attribute for validation. Similarly, undefined method model name and human attribute name. So currently, all of these methods are being called on our hash, our record, and so we need what we're passing into the presence validator to define all of these methods. And like I said before, we don't want to do monkey patching. We don't want to add read attribute for validations to every single hash in Ruby. So to fix that up, we can create another little class that I'm going to call the wrapper class. And now you're going to see the word new a lot in the next couple of slides. It's going to be weird, but just bear with me. So we can define a new method on wrapper. You can call to get a new anonymous class. And then you can call new on that anonymous class to get an instance of that class. And within this anonymous class, we're going to define our constructor. It's going to take in that hash. We're going to set up the errors with an adder reader going along with the instance variable so that we have that errors method defined. And then we're also going to define read attribute for validation, that second missing method, to just grab the value associated with the attribute that we're trying to validate. So this is pretty simple. We do have those two other errors that are still in there, and we can get those by just extending some built-in Rails modules, naming and translation, which also means that we're kind of on the path to get some internationalization in place, which is always great. And so then now, if we go to our validator and we set it up so that instead of passing in the hash to the validate each method as that first record argument, we now wrap the hash in our new instance of that anonymous class that wrapper.new is returning. Then we can go back, run our tests again, and it passes. And so now we have successfully validated the presence on a hash. And it's very simple. We just pass the hash in to the constructor, we call validates presence of, and it works. And this is pretty cool. Honestly, this didn't take as long as I expected it to, but I'm not going to call our proof of concept done quite yet. And that's because we're not supporting all of the options that we would normally have access to in our presence validation. So first off, if we look at allow nil, this holds true for allow blank, but I don't really know why you would ever use allow blank on a presence validator. We can check to see if rank is nil, and we're saying we're going to allow a nil rank. We still get the error, rank can't be blank. And so this means that something is going wrong. Something about allow nil isn't being taken into account. So if we go back to our presence validator, we saw that it inherited from each validator. And if we go to each validator, we actually see the code that handles these options directly in each validator's validate method. Underneath this a little bit, it calls validate each. So that tells us, okay, we're just bypassing the code we need. So if we go back to our validator, no longer iterate over our keys, just pass them into the constructor as we were before, and now call the validate method, passing in again our wrapped hash. It works. Pretty simple. But we have one more thing left before I'm going to call our proof of concept done, and that is supporting if and unless. So here we're saying it validates the presence of speaker if false, so it's basically saying never run this, but we still get the error speaker can't be blank. So now to fix this, again, we go back to our presence validator. This is kind of where we start whenever we're debugging this kind of stuff. I mentioned there was a bunch of comments that I wasn't showing on that first slide. So if we go back, we actually see in the comments, it tells us directly where to go. Go to class methods, validates. So if we pull up this method in the Rails source code, and this is the method that we're probably really familiar with from our active record models. If we're ever doing a validates first name, comma, presence true, it's that validates method that we're looking at right here. And so within validates, that then calls validates with, which we might know from running custom validators. Validates with then calls validate, validate then calls set callback. And this is pretty cool. This is where we've actually left ActiveModel behind entirely, and now we're in ActiveSupport callbacks. Because at the end of the day, we do have a lot of validation logic in Rails, but a lot of the validation paradigm is basically just two callbacks in a trench coat. And so if we look at callbacks, we see we've got our options here, if and unless. And now earlier, we're just calling the validator directly. We're completely bypassing that paradigm I mentioned earlier of registration and then running. And so this tells us that we need to hook into that callback code to get these options working. And so if we make a little change to our validator, where we now just delegate a bunch of things away to our wrapper and our wrapper class. And now we're delegating those class methods that we're used to from our active record models to our validation wrapper class, that anonymous class that's being returned by wrapper.new. And then we're delegating the instance variables to the instance of that class. And then meanwhile, on the wrapper side of things, we have a very small little update that we make, which is just include ActiveModel validations. This is great. We've got access to all of our validator methods and logic that we're used to at this point. And so then now, if we go back and check a simple little if and unless, then we get the behavior that we'd expect. And now we're also having to change things a little bit, where we're first registering that validation with the validates presence of method and then calling it with valid question mark. Now we're so close, and I've said this a million times, but we are very close to having the proof of concept. There's one thing left, and that's dependent validations. So this is where if you would have validates the presence of first name if last name. And so if we do a simple little test here where we want to validate the presence of bad jokes if Aaron, which, prevents probably a pretty big bug because that wouldn't make sense, no bad jokes, then we can run this code and it blows up. Undefined method Aaron. All the work the guy's done and no method named after him. And so here, this kind of makes sense because under the hood, we're basically still calling methods on our underlying hash object. And since the hash doesn't have methods that correspond to its keys, we don't have that method to call when we're using the if or the unless. And so in order to have those methods defined, we did basically convert our hash from key value pairs into method return value pairs. And we've got a lot of ways that we can do this in Ruby, method missing, a bunch of different delegator patterns. I'm just going to choose to use simple delegator because I like it and I don't think it's used enough, so I want to use it here. So here we change our new anonymous wrapper classes to inherit from simple delegator. In the constructor, we now wrap our hash in a data object. And so where we once had key value pairs, now we have basically a value object whose methods are the keys from our hash and whose return values are the values from our hash. And then we call super so that any methods that aren't defined on our anonymous class just get forwarded along to our new data object. So if we go back to our test, validate the presence of bad jokes, if Aaron, we get bad jokes can't be blank, which I think is a much better error message than anything I've actually written in production code. But yeah, and this is great because I mean, if you think back to the applications that you maintain and you imagine the bug that would be on the level of severity as in Aaron Patterson talk that didn't have bad jokes, you would know that we're really probably saving a lot of people a lot of money right now. The small laughter is the best laughter. All right, so now I'll say our proof of concept is finished. But we do have a couple of other things that we probably want to support, namely all of our other validators. And this is super easy with our current setup because it's just a bunch more delegate calls. We're just delegating all of these Rails methods to our little anonymous class that has that ActiveModel validations module in it. And the one thing that might be a little bit less familiar to everyone here is this clear validators bang method. This does exist on all of your active record models. You could call this in your application code so that suddenly in the middle of your app running, none of your validations exist anymore. I don't think that makes sense to do in production personally, but here where you have this more isolated state, it might make a little bit more sense to say, oh, I've set some things up, but now I just want to clear them all out because some weird condition has been met. The other thing that you will notice if you look at the tests for this, which I'll cover the tests a little bit later, is that we do have a little bit of a bug. And that bug is that if our underlying hash that we're validating changes or mutates after our validator has already been instantiated, particularly after that wrapper has already been instantiated, suddenly the wrapper just has access to the old state because that's what was used to instantiate that value object, that data object. But meanwhile, the hash has changed. So it might say, hey, bad jokes is blank when bad jokes isn't blank on the actual hash. And so we do have to get rid of our simple delegator, RIP, it did not last long. And we're just going to hold on to our object to validate that hash again in our instance variable in our constructor. We can bring back our read attribute for validation. That's just how it looked before. And now we'll handle that delegation through method missing. And so if the method is missing, check to see if it's a key on the hash. If so, return the value. Otherwise, do what you'd normally do. And the thing that's nice about the read attribute for validation pattern here is that because it's not just relying on methods being defined on our wrapper, this also means that you can actually validate things that match methods on this class, which isn't much, but if you wanted to say validate the presence of the errors in your hash, you can do this now because it'll actually be looking at the key value pair and not the errors method on the wrapper. This also means that you could do something like validating the presence of the nil question mark key value pair, but I don't know that there's many use cases for that. All right, and those are kind of the big things for the validator, but there are a bunch of other things that we could spruce up, add some bells and whistles. So first off, if our underlying hash doesn't actually have the key defined on it that we're trying to validate, it will currently blow up. Because if we were looking back at that if object-to-validate.key, else super, the super will just call no method error. That might not be what we want to do if we're validating, say, an incoming API request where we're expecting it to have some particular key value pairs defined on it. So maybe we would want to treat that as like a nil value rather than a no method error. And if you follow the link, I'll put these all in the Slack channel. Then you can see some code to handle this. Next up, all of our code so far is just assuming we're only passing in a hash. If you wanted to pass in a model or some other class, maybe that comes from a gem, then this commit will do that for you. Now this one is a little bit funny. So if we think back to our validator, we are exposing the typical Rails class methods as well as the typical Rails instance methods, all as instance methods on our validator class. And in Rails, we have a validate method on both the instance and class level. Validate on the instance level runs the validations. Validate on the class level is what you would use to run a custom method validation on your instances. And since we can't have multiple methods with the same name, I had to choose one to call validate. I chose the instance level one, but you probably will want the behavior that the class level validate gives you. And so you basically just create a little alias for it, and then you're all good. Custom validator classes are completely supported out of the box. We don't actually have to change anything about our current code to support your custom validator classes. But I do have an example in the repo that shows how you could actually set up a custom validator to run validations against arrays. So if you have an array of hashes and you wanted to validate that all of them have particular key value pairs, for example, you can do that with the linked custom validator. It's a little bit weird, it's a little hacky, but hopefully a decent proof of concept. Now the confirmation validator is kind of a weird one. I did not know this until I got some failing tests, but the confirmation validator actually does a little bit of metaprogramming with the thing that you're validating. Sometimes, maybe, sort of. And that can cause some breaking tests if you're passing in a hash. And so this is probably the hackiest thing that's going to be in this entire bit of code that I put together to support this, but it's kind of hacking around something that feels like a little bit more hacky than normal to begin with. And last, but certainly not least, I really love shoulda matchers. Shout out to Thoughtbot. I use these for testing all of my validations, all of my associations. And so I wanted to see if I could make them work with this pattern. And again, had to do something a little bit hacky, but did actually make it work. And it worked pretty well as far as I could tell. So I've got a link to a little support file that I put together, as well as the example specs that anyone can look at later on. So this is the repo. Again, I'll put all of these slides in Slack. And if you look at this repo, you'll see a bunch of commits, a bunch of branches. Every commit basically solves one problem, one that we either talked about today or added some kind of new feature, like the ones that I didn't get to talk about too much just a minute ago. All of the branches are basically different checkpoints, like the proof of concept, for example. And that is basically it. It's set up as a gem. It's not pushed anywhere. If anyone wants to push it anywhere, feel free to fork it and push it up to Ruby gems. But otherwise, as classic talks go, I did go a lot faster talking than I did in prep. So if anyone has any questions, you can feel free to shout them out now or come up to me after. The question, thank you for the reminder, the question was, could I give an example of when a hash might change after instantiating the validator? Is that right? Or after the wrapper, yeah. So in shoulda matchers, when you first set up your subject, which would normally be your model, your like described class.new, it first will test with, I don't know if it actually does the happy path or the unhappy path first, but basically it will first take the subject that you've set up in your RSpec test. Say I've set my bad jokes to false. And then if I'm validating the presence of bad jokes, or maybe in this case, the absence of bad jokes, then once it's validated, okay, this doesn't raise an error when it's absent, then it actually goes and changes the underlying object. In your active record model, it would be like model.badjokes equals true. So in that case, all of the shoulda matcher tests were failing until I swapped out the delegator pattern to actually keep track of the underlying hash. And so I don't think in real production application code, you're probably likely to see that happen. But it is good to know if you're in the habit of like duping something that you pass around, and then you maybe have some code that will modify it in place later, and the validator only has access to the dupe and not the original, then it might get a little out of sync. Any other questions? Yes?
What was your use case for using this validator?
Yeah, the use case for using this validator, so we have an event-sourced system at work, and so we have a lot of data that starts off as a hash, and because we don't use active record or any kind of real ORM, we either just have it as a hash or later on as like kind of like a custom value object, similar to the Ruby data class. And so because of that, and because of the requirement that I had that we didn't want to be setting up a new class for every different type of event in the system, I needed some way of just passing in an event, a hash event, into some object that could then run the validators against it. And so since we didn't have a model where we could just throw in the typical Rails pattern of validates this, validates that, had to figure out some new solution. Yes? Were both the readers and the writers essentially of the event using this pattern before it was sent over the wire? So the way that it currently works is that the source of the events can kind of change. We have a number of different events in the system. The ones that are most relevant to this particular pattern we call user-sourced events. And this is like something that starts off as params coming into a Rails controller, for example. And they just come in, get put in like a little hash similar to the params object. And then when they go into kind of the beginning of our event-sourced pipeline where we stuck the validation logic, eventually they get like written to a database and whatnot. When they first come in as a hash, that's where we validated them. We don't currently have any validation happening after they've already been written. So far, I don't think we've seen the need for that. It was mostly the case of with all of our events happening, they were naturally ordered based on when they occurred. And so if we had some event that we later found out was invalid or was broken, then fixing that past data could mean that we would have some ramifications for the data that's entered the system since then. So it got kind of complex and just saying, okay, before we actually persist this event in our event stream, we want to make sure it's valid. Otherwise, we're going to discard it. Discarding it then kind of triggers potentially down to like the UI raising like a little toast that says, you know, you didn't enter in the first name when you needed to or something. Are you asking where we store the events?
No, the validator.
Like the class that I showed?
So when you do validate, you add validate as a stuff.
Oh, yes. So that, the question is, where are the validations that we've registered kind of stored within the system? Is that right? Yeah, so that just leverages what Rails does by default, which we get from that include ActiveModel validations. And so under the hood, when you include ActiveModel validations, there's a class attribute called _validators that gets set up. And so when you do something like validates presence of, it basically appends to that _validators at the class level. And the way that the class attribute is set up is that it can just be, if you have like a series of class ancestry, like model inherits from other model, inherits from other model, then if I remember correctly, the subclass has kind of its own version of the class attribute that pulls in the parent. And so if you've ever had like a single table inheritance active record model setup where you have a base class that has some validators defined, and then you have a subclass that adds more, that subclass will have not only the ones defined on itself, but the superclass as well. And so long story short, _validators, it's a method that you can call on your active record models on the class level if you ever want to see all the ones that have been set up. You can also look at, I think it might just be the callbacks method, and that kind of shows you how all of the validators tie back to just callbacks that are set on your models as well. Let's see, and I am out of time. So thank you all again for coming. If anyone has any more questions, feel free to flag me down.